Hello children. So today we are starting with the new chapter inverse trigonometric function, which I told it is going to be the most important chapter, which is like a foundation for all the calculus related part of your mathematics, not only in second PUC, not only in the 12th standard, but also in the further higher education. Okay, now let's come to this basic. Before getting into the ITF chapter, I shall make you recall certain things about functions. See, a function is said to be a one-one function. I shall show you with small figures the way I have taught you before. So, a function from A to B is said to be a one-one function if there is a one-to-one correspondence. So, this is a one-one function irrespective of many free elements in codomain. This is domain and this is codomain. In codomain, if there are free elements, it is called as an onto function. Okay, it's called as an into function. This is an into function, but it is a one-one function because one element of domain has exactly one unique image in this that will form a function. But in codomain, if at all a element is acting like an image, it is image only for one element. See, if at all the arrows has come to the elements in codomain, only one arrow should have come. Then it is called as an one-one. It's called as a one-one function. So now this is one-one function. But when you want to write, so I shall show you the inverse mapping of this. We have learnt like this priorly also. So now I am trying to write F inverse from B to A of this. Okay. So you have A, B, C, D, E, F in the codomain, which will form domain now. A, B, C, D, E, F. And in domain you had 1, 2, 3, 4 that will form codomain now. And I shall do the same mapping. 1 is related to A, so I shall relate A to 1. And 2 is mapped on to D, so D to 2. And 3 is mapped on to B, so okay, B to 3, 4 to E, so E to 4. Okay. Now, do you think this is a function? I told you the reason here. Every element here is having one arrow coming out of it. No element is free. So, this is a function. And since any element which has got the arrows here is only one in codomain, and so this is a one-one function. When you want to find out whether it is a function or not, you are going to see only the domain. And if it is a function, further you will check out the conditions in codomain and decide what kind of function it is. So here we decided it is one-one function because the elements are acting as image only for one element. So there is a one-to-one correspondence, therefore it is one-one function. Now I'm trying to write the inverse mapping of the same function, but when you see here, you can see that the codomain here has become the domain and the domain here has become the codomain when I'm trying to write the reverse mapping. I'm trying to write the reverse mapping, but it is not at all a function. Why? See, you have C without acting as an image and you have F without having an image, not acting as an image. The C and F are free elements without having any image, and therefore this cannot be a function at all, and therefore F inverse does not exist for this function. So here I'll write F inverse does not exist. Okay. Now I shall take one more function. Though this was one function, its inverse did not exist. Now I am taking next is onto function. And if you can recall, this one function is also called as injection. This is injection or it is one function. Okay. So now I am writing onto function. Onto function is also called as surjection or surjective function. Surjection. So how had we learned this? Again I shall write a small figure for you so that you can grasp it very quickly. This is f from a to b. It is onto function. So now I shall write 1, 2, 3, 4, a simple example, and I shall take up a, b, c. Okay, 1 to a, 2 to a, 3 to b, and 4 to c. Okay, now is this a function? I am going to look into the domain to know whether it is a function or not. Yes, every element has been occupied, has only one image, that is only one arrow has come out of it, and hence this function, this is, or this mapping is a function. What type of function is it? I am coming to codomain. In codomain, there are no free elements here. All the elements have one or the other pre-image there. Therefore, this is an onto function. There are no free elements here. Therefore, this is an onto function. Now again, just like this, I am going to try to write the inverse mapping of this and find out whether it is a function or not. So let us do, and I guess by this time you would have recalled like how we had learned before. F inverse will be from the same, for the same function, it will be a reverse mapping from B to A. B is having 3 elements A, B, C, and the A is, the set A is having 1, 2, 3. 1, 2, 3, 4, and this is my domain now, and this is my codomain. I shall do the same mapping. A should be mapped onto both 1 and 2, A to 1 and A to 2, and B to 3 and C to 4, I guess. Okay, yeah. And now, is this a function? No, it is not a function. This is not a function because in domain, you see that there are 2 arrows coming out of one. So, element is not having a unique image, instead it has 2 different images. Therefore, this is not at all a function. I am writing the reverse mapping of this f, but it is not at all a function, and hence here also I say f inverse does not exist for this mapping. It does not exist. So after I write the reverse mapping also, if f inverse is also a function, then only we consider that that particular function has its inverse, we say like this. And now I shall give you one example. Okay, now let me tell about f inverse also. So when does f inverse exist? F inverse will exist when, after writing the reverse mapping, it should still be a function. And when does it happen? As we have learnt in relations and functions chapter, it happens only when it is a bijection or it is a 1-1 onto function. The name itself will tell that the function will have its inverse only if it is both injection as well as surjection, or it is both 1-1 as well as onto function. Okay, so now let me come to another mapping, f from A to B, which will have equal number of elements, and A to 1, B to 2, C to 3. A simple way of understanding that this f has its inverse. This is domain and this is codomain, and I am trying to write its inverse, f inverse from B to A. Then B will have 1, 2, 3, A will have A, B, C, and the still mapping is the same. And you can see that after writing f inverse for this particular function, you can see that they have equal number of elements and the same mapping is done. Both the conditions of 1-1 function and onto functions are satisfied here. I will come here, this here. See, every element is having a unique image, therefore this is a function. Come to codomain, every element has only one arrow coming to it. The meaning is every element is image for only one element here, therefore this is 1-1 function. What is an onto function? There should be no free elements here. So we see that codomain, every element is occupied and there is no free element here, therefore this is also an onto function. So this is both 1-1 as well as onto function, or I shall call this as what? It is a bijection. It is a bijection. And when I am writing its f inverse also the same. From domain to codomain, you have every element having a unique image in codomain, therefore this is a function, and every element is having only one arrow coming to it, so that it is 1-1, and there are no free elements here, therefore it is onto, and hence this is a function. It is 1-1, it is onto. And then when we say f inverse exists, of course the reverse also will be true. F inverse you can write again inverse, which will be the F inverse whole inverse will be equal to what? F inverse whole inverse will be equal to the function back. But for a function, the main point what we have to understand now is, if a function has to have its inverse, then it should be both 1 1 as well as onto. So this function is both 1 1 and onto, and hence its F inverse is existing. Now all this was a part of your relations and functions chapter, and now let us get into the inverse trigonometric function, and I shall tell you what is the meaning of inverse trigonometric function, and will it have its inverse. Now let us try to understand. Okay, you have learnt about trigonometric functions before, and I shall tell y is equal to sine theta. I shall take some examples now. I shall tell 1 by 2 is equal to sine 30 degrees. Then, okay, even before that, 0 is equal to sine 0 degrees. Then, 1 by root 2 is equal to sine 45 degrees. Root 3 by 2 is equal to sine 60 degrees. 1 is equal to sine 90 degrees. And I shall write one more, in another only one more, minus 1 is equal to sine of minus 90 degrees, because sine of minus theta is minus sine theta, minus sine 90. Now these are all something very familiar for you, what you have learned in the previous standard, in 11th standard or in first PU. Now I am trying to tell you that this is a trigonometric function, and when I transpose to the other side, it takes the inverse trigonometric function. Now the more told about these functions, the more confusion. So in a very simple way, understand it very precisely. I shall tell you as less as possible and make you understand. Now when I am transposing sine that side, we cannot write like this. Like for example, you have x is equal to 3y. Now I can't write x, I can write x by 3 is equal to y. This was into 3 is an independent term, y is an independent term, and when I am pushing off this 3 to the other side, it is though, because it is multiplication, it has taken the it has come to the denominator, and when cross multiplied we get back the same thing. Now this is what you do in algebra, in arithmetic. But when it comes to a function where you are breaking up the what do you say, the heart and the body part, like this, you have sine theta is entirely one function. There is no breakup the way we took here 3 and y. Okay, it was not like that. It is not 3 into y. This is not sine into theta. This is sine theta. This is the sine of the angle theta. So theta is a part and parcel of sine. And if I have to transpose sine to the other side, that becomes sine inverse y. Sine inverse y is equal to theta. It's like this. So now you see, one part you have to understand now, you have to get used to is, when I give you degree along with sine, the trigonometric function. So trigonometric function will always have the angle. Theta is the angle. So if you put the angle here, outside you get a real number. These are all real numbers. 1 by 2. My y is a real number. So this is real number. And this is angle with trigonometric function. So this should be exactly the vice versa when you do here, is it not? So see, this should be angle, outside you get angle when you write inverse trigonometric function of some real number. Okay, inverse trigonometric function, ITF I'll write. Inverse trigonometric function of real numbers should be equal to angle. So from now on, when you see inverse, you please understand that if you have inverse trigonometric function, beside that it should have a number, and outside you have to tell the corresponding angle, to what angle that number comes out to be. So now I shall write exactly the vice versa of this. So how do you understand now? This is sine inverse y is equal to theta. That is the inverse trigonometric function of this trigonometric function. So this becomes sine inverse 0. Sine inverse, the number 0 is equal to 0 degree, or we write it as 0 pies. In inverse trigonometric function, it is like appropriate only when you use radians for the angles and not the theta, but still not the degrees. But still we write the degrees now so that you understand perfectly. This will be sine inverse half. So sine of what degree is equal to half should be your answer. Sine of what degree is half? It is 30 degree. So this is 30 degree. Likewise, sine inverse 1 by root 2, sine inverse 1 by root 2 will be equal to 45 degrees, or it is equal to pi by 4. This will be pi by 6, this will be 0 pi's. And sine inverse root 3 by 2 is equal to 60 degrees, which is equal to pi by 3, and so on. Sine inverse of minus 1 will be equal to minus pi by 2. Continuing, I have skipped this and I have written this. Okay. So now you see sine inverse of minus theta is equal to minus sine theta. Now minus theta, is it not? Minus the angle. If you have sine inverse, if you have to tackle the minus inside inverse trigonometric function for sine, for the sine function, then you have to simply bring out the minus and write the angle. With this, when you are writing this, you understand this perfectly. Now, so the concept here in this particular step, what we learnt is, if you have inverse trigonometric function, along with inverse trigonometric function, you need to have a number, and the answer will always be an angle, and in which is exactly the vice versa of trigonometry. So please have a vision in your mind that trigonometric function will have angle, inverse trigonometric function will have its number, and what is the answer will be the ulta of that. Okay, now after this, can I write sine inverse first of all? I only told you how you can write this inverse function. I have transposed and I have written, I told you. It is not exactly the transposition. It is writing the inverse of that. We don't tell transposition, but I just wanted to make you understand. Now, first of all, can I write like this? Because there is a particular reason. Now I shall tell you. You know, this inverse trigonometric function are not supposed to have their inverses at all. They should not have their inverses, but still I am writing inverse. How is it? And how I can write, to what extent I can write? There is certain limit, there is some certain range to what I can, to what extent numbers, to what numbers I can take. I cannot take all the numbers possible for sine. It's not possible. Okay, so now I shall show you something. See, if I say, see, sine theta y is equal to sine theta is my function, and this is a function from real numbers to real numbers. It is a function from real numbers to real numbers, and you can imagine that this real numbers will have all plus and minus numbers, is it not? So this is a function. So you can relate to your 1 1 and on to also, as I am telling. Now say, okay, now I shall write for 0. For 0, what is the, put 0 in this place, sine 0 is 0. So I shall map this to 0 degree. 0, sine 0, this is a real number 0, sine 0 degree is equal to 0. And degrees also is a real number, please understand. Yeah, don't get confused. I'm writing, I'm taking all these numbers and putting here. So this will be the degrees, and these are all the outcome, the real numbers, whatever that comes out. Okay. So now 0. Now what is sine 180? Sine 180 degrees. Sine 180 is also 0. So I'll keep writing here. Sine 0 is equal to 0. Sine 180 is equal to 0. Sine of minus 180 is also 0. Sine 360 is 0. Sine of minus 360 is also 0. So I have 0 here, and I have minus 180. I have 360. I have minus 360. In between you have several other real numbers, infinite number of course, but I am taking certain numbers only to make you understand the function. So all are mapped onto this. Okay, and I shall take like etc. And I have taken only for one value like this. All the values of sine and sine theta will be lying only between sine 1 and minus 1. The rest all will be free. Okay. So now first of all, the first condition, is it satisfied? What is the first condition? For a function to have its inverse function, if to have its inverse, it should be 1 function, it should be onto function. Only when these two functions are possible, if it is both, then only it will have its inverse. Now see, I have plotted y is equal to sin theta trigonometric function, and from trigonometric function only I should get its inverse. Now is its inverse possible when I am writing like this? Y is equal to from f, from r to r, you see that 0 also 0, 180 also 0, 360 also 0, minus 360 also 0. This is not a 1 function at all. It is not 1. Okay, is it on 2? See, you will have 2, you will have minus 2, and you will have 3 dot dot dot, you will have minus 3, and so on, and many other fractions also will be there. Now, is it possible for you to have any value, any degree of sine to be 2? No, it's not possible. Sine of any degree is not equal to 2. All the sine values will lie. So, sine theta, all the values are lying only between minus 1 and plus 1. It cannot lie lesser than, it cannot have any value which is lesser than minus 1 or greater than 1. All the sine values will be only between minus 1 and 1. So, the first condition is that 0 is image for many infinite number of numbers here. Therefore, it is not 1, and 2, what is this? 2, 3, 4 belonging to codomain, do not have image, do not form image at all. Therefore, it is not onto also. All the numbers other than minus 1 to plus 1, the rest of all numbers are free without being image in the codomain. Therefore, it is not onto. It is not 1, it is not onto. How can it have its inverse? It cannot have its inverse. So, there is something called as principal value, the branch of the function, principal value branch of the function. So, there is certain condition. Every problem in inverse trigonometric function has its own conditions, so that we get the proper inverse only in that particular branch. See, sin theta is valid, all those degrees are valid only if I can take so that the value will be only between minus 1 and plus 1. I can write sin inverse 1. I cannot write sin inverse 2. This is very much wrong. I don't have any value for sin inverse wherein I can write any number less than minus 1 or greater than 1. I can't do that. All the sine values and the cosine values are lying only between minus 1. We get the values only between minus 1 and plus 1. Now, I am talking only about sine. Now, likewise, you have certain range of values which are available, which will be holding good for secant theta, cosecant theta. You see, when you draw the figure for sine theta, if you have this, I have told you in the previous class also, this will be plus 1, this will be minus 1, and I shall take a plus 1 line here, minus 1 line here, and then you see all your, this is sine 0 is 0, your sine wave will be like this, and your cosine, while cos 0 is 1, right? So, your cosine wave will be like this. Okay, so I'll write this is sine wave, this is cos wave, and all your secant and cosecant will be above plus 1 or it will be below minus 1. You will have secant theta and cosecant theta, on the upper place, on the upper part of the graph or the lower part of the graph of plus 1 and minus 1 respectively. In between you will have sine. So, now you have a particular range where you can take its inverse. Okay, so you cannot take inverse anywhere and everywhere. Now, though I am taking sine and cos from everywhere, from here till here, I am taking everything. See, real numbers, I am taking all the real numbers. X axis will have the real numbers. On the real numbers, I am taking all the x values, for which my y values will lie only between minus 1 and plus 1 in trigonometry. So, my graph is entirely indefinite on both the sides. in towards minus infinity and towards plus infinity. But where can it have its inverse? I cannot have its inverse all the time because that function is neither 1 1 nor on 2. So now let me draw the graph for you. When this sine curve will have its inverse. Now in that case, if I say that the sine function cannot have its inverse, then none of the trigonometric functions can have its inverse. But still we use inverse of every trigonometric function. How are we doing this? So what we are doing is, a simple logic is, I am going to take a certain interval of the sine wave where it is exactly 1 1 as well as on 2. So only in that particular part the sine function will have its inverse, not all the places. So where is it? I shall take okay, and if I want I can go further also, but I don't want to. So I shall take this as plus 1, this as minus 1, and then I shall take this as my pi by 2, this as my 1 pi by 2, 2 pi by 2 will be pi. Okay, let me take the last one also, and this will extend. Pi by 2, 1 pi by 2, 2 pi by 2, 3 pi by 2 you will have, and here I shall write minus pi by 2, and then you will have minus pi, and then you shall have minus 3 pi by 2, and so on. And we have the value, right? Sine 0 is 0, sine 90 is 1, sine 180 is 0, sine 270 is 0, and sine of 360 is 0. So I shall take here. Then sine of minus 90 is minus 1, sine of minus 180 is 0, and then sine of minus 270 is plus 1, and then it will be 0. So your sine curve is like this. Yes, your sine curve is like this, and this is minus pi. Your sine curve is like this. Now you see, in when you are plotting quadratic equation graph, you have learnt like this. If your graph is cutting your x-axis at two places, we say this curve is having two values of x. Okay, and if one equation is having two values of x, then we say that it is not 1 1. If the curve is cutting x-axis twice, thrice or more, then it is not 1 1. It has to have only one cut on x-axis to be 1 1 function. But then now you see here the sine curve, when you extend infinitely on minus to minus infinity till plus infinity on the number line with angles there, then you can see that your sine theta will be cutting x-axis infinite number of times. Therefore, sine will get its value 0 for infinite number of theta. Sine will get its value as 1 by root 2 for infinite number of angles. Now that will not make it as 1 1 function. I want to have only 1 by root 2 one answer. I want to have only 1 as the answer. I want to have only 1 0. Now when you look into your trigonometric table, you have 0, sine 0 is 0, 1 by 2, 1 by root 2, root 3 by 2, 1. And the same thing on the other side, you have minus 1 by 2, minus 1 by root 2, minus root 3 by 2, minus 1. Now in these minus 1 to plus 1, your values will not get repeated. Okay, all the values of your sine, whatever you put thousands of degrees also, sine of like 27 times 360 degrees, anything like that, thousands of degrees also, you can always reduce it to a value which will be only between minus 1 and plus 1, which means that the x-axis will be cut only once between minus 1 and plus 1. So let us see here, you have plus 1, minus 1 and plus 1. The sine value will start from here, it will cut only the x-axis only once and go up there. Okay, so the x value, the x axis will be cut only once between minus pi by 2 and plus pi by 2. Not even this, I cannot take this also. If it has to cut x axis only once, then it has to be only between this. So let me write a thick line there. You see, in this part of the graph, the sine theta, the sine curve, y is equal to sine theta curve is cutting x axis only once. And for every value, there is a different y value. For every x value, there is a different y value only in between this. And once you reach this place and come after that, see, this value will be the same as this value. These two will be same, these two will be same, these two will be same. So whenever you take the y value start getting repeated. So if the y value is to be only one value for every theta, then that has to happen only between minus pi by 2 to plus pi by 2. So this is, so minus 1 less than or equal to sine theta is less than or equal to plus 1 when theta is in between minus pi by 2 less than or equal to theta less than or equal to pi by 2. Now this is the way we write. Once I start telling about these intervals, you will start getting confused. So please understand only by the figure and understand perfectly for sine, and the corresponding explanation will be the same thing for cos, secant, cosecant, tangent and cotangent of the angle theta. So you have here, when I say y is equal to sine theta, now I am coming to domain and range. Slowly getting into domain and range. When I say the function y is equal to sine theta, what all theta valid values I can put inside theta, that is called as domain. And for that particular value, what all answers I will get, that is called as range. So now when you come to inverse trigonometric function, I don't have any restriction between the minus pi by 2 and plus pi by 2. I have theta belonging to real numbers. You put any kind of real number, thousands of degrees also, but all the values will be lying only between minus 1 and plus 1. But when it comes to inverse trigonometric function, if I want this function to have its inverse, then the graph should be cutting x-axis only once. That can happen only between the angle minus pi by 2 and plus pi by 2. Once I go beyond minus pi by 2 and plus pi by 2, the x-axis is again cut and the values are getting repeated. This value will be as good as this and this, and so I cannot take the values where it is getting repeated. Inverse exists, so I will write therefore inverse of sine theta exists only between minus pi by 2 and plus pi by 2. So when I am taking inverse functions, I have to take the graph only between minus pi by 2 and plus pi by 2, wherein my values also will be lying only between minus 1 and plus 1. Okay, now this was like how I am getting inverse function and why the conditions are there. And so these are called as the principal value branch of the function. And I explained everything in terms of trigonometry because you already know about trigonometric function. So now we have a graph here. Now in the graph also I should explain, and we shall go to the inverse graph of that. There too I will explain. See, you have a sine theta, sine graph here. So it was the same graph what we saw till now, plus 1 and minus 1, sine 0 is 0, sine 90 is 1, sine 180 is 0, sine 270 is minus 1 and so on. This is a sine graph. We see that the sine wave is crossing x-axis infinite number of times. So everywhere you cannot have its inverse function because it will not be 1, it will not be on 2 when I am taking the entire range. But this part of the graph where you see minus pi by 2 plus pi by 2, all the angles are different and all the values are also different only in this function. There is no break also in between in the graph, and we get our inverse function like this, where I am changing my where I'm changing my domain and codomain. See, in the previous graph you see the angle was on x-axis and +1 and -1 real numbers was on y-axis. So to get the inverse function, what should we do? We should interchange our domain and codomain, is it not? So now we are changing our domain and codomain to get the inverse trigonometric function. So this is the graph of y is equal to sine inverse x, where x should be a real number and y should be also a real number, but it is in terms of angle, that too in what? In pi's. Preferably in inverse trigonometric function we prefer an angle which is in pi's. So now this is y is equal to sine inverse x curve, where the angles have come on y axis and the real numbers have come on x-axis, and now you see the graph is cutting y-axis many times, which is not a problem for us, but on x-axis it is exactly cutting only once here. So this is called as, here we take the principal value branch. Now what do you mean by that? So now when I say y is equal to sine inverse x, what all you can put the values for x? With inverse trigonometric function you should have what? Number, is it not? What numbers can you put? What valid numbers can you put for sine inverse? You can put only between -1 and +1. So here you know the domain is equal to -1 to +1 closed interval. What do you mean by closed interval? -1 and +1 included, and all the infinite decimals, like any kind of numbers which is existing between -1 and +1 are included for this, and all those are the values which I can plug in inside x to get the particular values. So what is your range then? What are you going to get range? Range will be what? From what angle to what angle you get? You get only between -π/2 to +π/2. This is called as the range, and hence now we have the domain and the range of a inverse trigonometric function. So you understand that in inverse trigonometric function there are certain conditions, and that condition we call as the principal value branch of sine theta. See, this is the principal value branch where domain and range are taken. Okay, and all these depends on where we have the graph cutting x-axis only once, and every value should have its own unique value. How many values? Only one value. So inverse trigonometric function can be existing for all trigonometric functions. Will have its inverses, provided you are taking them in a certain interval. So now let us see, we have a table here. See, you have principal value branches for all the functions similarly. See, as we saw for sine theta. See, now I want you to understand like this. For sine inverse x, what is the domain? So this is our domain and this is our range. The domain and this is the range, or we call it as principal value, it is PV. Okay, range is also called as principal value, and this forms a very important part for JEE objective question. One question will come on this, and this is also an integral part of your board examination paper for 1 mark. Okay, very important. And now you see sine. This domain should always be a number which will be from -1 to +1, and we know that sine and cos both will have the same kind of domain. So see, cos also will have -1 to +1. Now I want you to understand like this. What is the reciprocal of sine? Cosecant. What is the reciprocal of cos? Secant. Cosecant and secant will be the graphs which will be on the alter part, on the upper part of sine and cos, and the lower part, is it not? So that means I should take the entire real numbers other than -1 and 1. So see, sine is having domain as -1 and 1, whereas sine reciprocal cosecant will have all the real numbers except the values between -1 and +1. -1 and +1 are included, or we have to subtract here, are included for cosecant also. We have taken for sine also -1 and +1. So they touch there at that particular point, and the rest in between values are not taken by cosecant inverse. Similarly, the same thing will be holding good for secant also, because cos also has the same domain. So what is the domain for secant inverse? R minus, see, these two are same. So I want you to remember like this. For sine it is like this, So other than this, the rest all real numbers will be holding good for secant and cosecant, which are the reciprocals of cos and sine respectively. Okay, with all this, what are all the values that you are getting? How do you remember? You remember like this. For sine, I know for this, the range is between minus pi by 2 and plus pi by 2. Same thing holds good for cos also. And other than this, sorry, cos, I'm sorry. Cos of minus theta is minus, cos of minus theta is cos theta, is it not? We know that cos of 180 is equal to cos of 180 is equal to minus 1, and whereas cos 0 is equal to 1. That is why minus 1 to plus 1 we take from 0 to pi. So the range will be from 0 to pi, and now how do you remember to take for the reciprocals? Reciprocal of sine is cosecant. In cosecant, we shall take the same values between minus pi by 2 and plus pi by 2, except for one value where you get infinity as the answer. Infinity are not defined as answer. Which is that? That is 0. Sine 0 is 0. Let me write the note points here. So the reason I am writing, sine 0 degree is 0. So what is cosecant 0 degree? Cosecant 0 is 1 by 0, which is equal to infinity. So I am not taking 0 degree here for cosecant. See, for cosecant it will be the same thing, minus pi by 2 plus pi by 2, but without the 0, because it will be not defined at that particular point. Similarly, when I say cos 90, cos 90 is 0. So what is secant 90? Secant 90 is 1 by 0, which is equal to infinity. So for secant I am not taking 90 degrees, except that the rest all degrees I can take. So where all I can take, just like cos 0 to 180 you will take for cos and secant. So 0 to 180, but here for one value you are going to get not defined, and so that is the 90 degree minus pi by 2. I want you to remember like this. Now that was for sine, cos, cosecant and secant. When you come to tan, there is a bit of difference when you are understanding here. For tan and cot, any kind of numbers will do. It exists, it will have its domain, any kind of numbers will come. All the tan exists from minus infinity to plus infinity. So here tan will have any real number as the domain, cot also, but when it comes to range you have to remember particularly. For tan it is minus pi by 2 to plus pi by 2, because from minus infinity to plus infinity. But when it comes to cot, see here it is from 0 to pi. The way you take for cos, it is from 0 to pi. Where is cot negative? Cot is a relation which is equal to cos theta divided by sin theta. So it's always related with cos, which is the numerator, and that cos is having the interval, the domain range principal value branch between 0 and pi, where 0 and pi are included. When it comes to cot, this is 0 to pi, which is where you don't take 0 and pi, because it is not defined at that particular point. So it's a open interval. It's closed interval for cos, whereas for cot it is 0 to pi. Okay. Now this is a very important part of inverse trigonometric function, the special part where you can understand that every trigonometric function cannot have its inverse. It can have its inverse provided we take only a part of the graph where every x value from the domain will have a unique value in the codomain y, and all the elements in y also should be occupied. Therefore, all trigonometric function will have its inverse trigonometric function, it will have its inverse provided we take the proper domain, the valid domain, and it will have its own valid range also. So this is the table which you should know by heart. Okay, and now there is something like regarding this inverse trigonometric function, there are certain things that you should know. Okay, which are like there should be no wrong usage. See, when I say sine inverse x is the inverse trigonometric function. It is not equal to sin x whole power minus 1. When I say in arithmetic 2 power minus 1, this is equal to 1 by 2. Likewise, the entire trigonometric function to the power of minus 1 will be 1 by sin x, and this is not equal to sin inverse x. They are all different. Sin inverse function tells you it is an inverse trigonometric function, whereas sin x whole power minus 1 is whatever the value that you get here, you are writing it as 1 by sin. So like for example, if this was See, suppose you have sine 30 degree whole inverse, then this will be equal to 1 by 2 to the power of whole inverse, which is equal to 2. So, this is, you don't have something called as sine inverse 30. It does not exist only. Why it does not exist? With inverse trigonometric function, I cannot have a degree at all. I should have a value. Okay. So, sine inverse x and sine x whole power minus 1 are not the same. That is about your first point what you see here. Sine inverse x should not be confused with sine x whole to the power of minus 1. And whenever no branch of an inverse trigonometric function is mentioned, we mean the principal value of that function. What do you mean by this? From now on, when you see, look at the questions from inverse trigonometric function, you can always see that, like for example, I'll tell you, I shall say 2 sine inverse x is equal to sine inverse of 2x into root of 1 minus x square. Then we write like this, minus 1 by root 2 less than or equal to x less than or equal to 1 by root 2. See, from now on, every other expression inverse trigonometric function is going to have a condition like this. Why? We every time we tell that this inverse trigonometric function will exist if and only if x is taking the values only between minus 1 by root 2 and plus 1 by root 2. This is a condition. And now when you are doing the problems, please keep all these conditions beside and start working on the problem, because they would have given the appropriate condition for x there. You need not get confused. That's only to tell that, because I cannot just tell that it is prove that this one I cannot tell. I should always give you the condition where it is valid. And many a times in objective question, they will ask you question like this, what are all the values of x that holds good for this expression, 2 sine inverse x is equal to sine inverse of, and so and so. They give you like this. And now, the meaning of the second statement is, suppose I don't give you this. Suppose I don't give you this, then it should be understood that if I don't give you anything, you should understand that it is always the principal value branch of that particular function, and that will be taken not with this kind of provings, it will be taken with the small trigonometric functions with the values. Okay, now point number 3, the value of an inverse trigonometric function which lies in the range of principal branch is called as principal value of that inverse trigonometric function, or this principal value branch is also called as, now from now on we will call it as PV. It's called as what? It is called as the range for us. It is the range. So in the question they may ask you range, or they may ask you the principal value branch. So whenever I mention that only certain kind of answers will come, those answers are said to be of the principal, belonging to the principal value branch. Okay. Now that we have looked into the theory of inverse trigonometric function, now we shall continue with certain values. Just now, in the initial part what I told you, like from the trigonometric part to inverse trigonometric part, when I give you sine inverse of 1 by root 2, what is the angle that you should write? Based on this, let us see certain problems, and after that problems we are going to do the properties, where I start proving all the theorems of, we say properties, we say theorems, but they are all the conditions that you should know for sure.